To obtain 120/208 single-phase power, a dedicated transformer is required. It is not possible to derive 120/208 single-phase directly from a 120/240 single-phase supply. The transformer must have specific characteristics to meet the X-ray machine's needs. The primary voltage of the transformer should be compatible with the existing supply, so in this case, 120/240 volts AC. The secondary voltage must provide the required output of 120/208 volts AC. The power rating of the transformer needs to be sufficient to handle the power demands of the X-ray machine. Consult the X-ray machine's specifications to determine its power requirements and select a transformer with an appropriate power rating, typically expressed in volt amps or kilovolt amps. The installation process involves several key steps. Firstly, selecting a suitable location for the transformer. The location should be convenient, accessible, and near the X-ray machine to minimize voltage drop and wiring distance. Ensure adequate ventilation and clearance around the transformer for heat dissipation and maintenance. Secondly, physically installing the transformer. Mount the transformer securely on a stable surface or wall, following the manufacturer's instructions. Use appropriate hardware and mounting techniques to ensure the transformer is properly supported. Thirdly, connecting the primary windings. Connect the primary windings of the transformer to the 120/240 volt single-phase supply. Ensure the wiring is correctly sized and installed according to electrical codes and regulations. Use appropriate connectors and terminations for a secure and reliable connection. Fourthly, connecting the secondary windings. Connect the secondary windings of the transformer to the X-ray machine. Again, ensure the wiring is correctly sized and installed according to electrical codes and regulations. Use appropriate connectors and terminations for a secure and reliable connection. Fifthly, verifying the voltage and phase. After completing the wiring, verify the voltage and phase of the output to ensure it meets the specifications of the X-ray machine. Use a voltmeter to measure the voltage between the different phases and neutral. Confirm that the voltage is within the acceptable range and the phase sequence is correct. It is strongly recommended to consult with a qualified electrician for the installation and wiring of the transformer and X-ray machine. Electrical work can be dangerous, and it's essential to ensure that the installation is done safely and correctly. Proper grounding is crucial for the safety of the equipment and personnel. Ensure that the transformer and X-ray machine are properly grounded according to electrical codes and regulations. Use appropriate grounding conductors and connections to provide a low impedance path for fault currents. Overcurrent protection must be provided for the transformer and the X-ray machine. Install circuit breakers or fuses to protect against overloads and short circuits. The size of the overcurrent protection devices should be selected based on the transformer's and X-ray machine's current ratings. Always refer to the manufacturer's instructions for specific requirements and safety precautions related to the X-ray machine and transformer installation. The manufacturer's instructions will provide detailed information about the equipment specifications, installation procedures, and safety guidelines. Ignoring these instructions can lead to equipment damage, personal injury, or even death. Some transformers may require additional considerations such as ventilation or cooling. Ensure that the transformer is installed in a well-ventilated area to prevent overheating. If necessary, provide additional cooling, such as fans or air conditioning. Before working on any electrical equipment, always disconnect the power supply and verify that the circuit is de-energized. Use appropriate lockout/tagout procedures to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment when you are tired or under the influence of drugs or alcohol. If you are not comfortable working with electrical equipment, always seek the assistance of a qualified electrician. Electrical work can be dangerous, and it's essential to take all necessary precautions to ensure your safety. Regularly inspect the transformer and X-ray machine for any signs of damage or wear. Check for loose connections, frayed wires, or other problems. If you find any problems, have them repaired immediately by a qualified electrician. Keep the area around the transformer and X-ray machine clean and free of obstructions. This will help to prevent accidents and ensure that the equipment can be easily accessed for maintenance. If you are unsure about any aspect of the installation or operation of the transformer or X-ray machine, consult with a qualified electrician or the manufacturer of the equipment. They will be able to provide you with the information and assistance you need. Here are some additional considerations. Consider the efficiency of the transformer. Transformers are not 100% efficient, and some energy is lost as heat. Select a transformer with a high efficiency rating to minimize energy waste and reduce operating costs. Consider the noise level of the transformer. Some transformers can be quite noisy, which can be a problem in quiet environments. Select a transformer with a low noise level if noise is a concern. Consider the size and weight of the transformer. Transformers can be quite large and heavy, so it's important to select a transformer that is the right size and weight for the available space. Consider the environmental conditions in which the transformer will be operating. Transformers can be affected by temperature, humidity, and other environmental factors. Select a transformer that is designed to operate in the specific environmental conditions. Consider the availability of spare parts and service. It's important to select a transformer from a reputable manufacturer that offers good service and support. This will ensure that you can get spare parts and service if you need them. The NEC, or National Electrical Code, provides guidelines for the safe installation of electrical equipment, including transformers. Adhering to the NEC helps ensure electrical safety and compliance. Article 450 covers transformers, outlining requirements for installation, protection, and ventilation. NEC Section 450.3 covers overcurrent protection for transformers, specifying the maximum overcurrent protection device ratings based on the transformer's rated current. NEC Section 450.11 addresses transformer installation in ventilated areas to prevent overheating. NEC Section 250 covers grounding and bonding requirements, ensuring a safe path for fault currents. These sections, and others in the NEC, are important for ensuring a safe and compliant installation. Always consult the latest edition of the NEC and local electrical codes for specific requirements in the area. Table 450.3a in the NEC provides guidance on the maximum overcurrent protection device ratings for transformers rated 600 volts or less. Table 450.3b covers overcurrent protection for transformers rated over 600 volts. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault currents, helping to prevent electrical shock hazards and equipment damage. The grounding system should be properly installed and maintained to ensure its effectiveness. Grounding electrodes, such as ground rods or ground plates, should be installed in accordance with the NEC. Grounding conductors should be properly sized and connected to the grounding electrode system. Bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault currents. Bonding helps to prevent voltage differences between metal parts, reducing the risk of electrical shock. Bonding conductors should be properly sized and connected to all metal parts of the electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices should be properly sized and installed in accordance with the NEC. Circuit breakers are resettable devices that trip when an overcurrent occurs. Fuses are one-time devices that melt and open the circuit when an overcurrent occurs. The selection of overcurrent protection devices should be based on the ampacity of the conductors being protected and the characteristics of the load. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. SPD diverts surge current away from sensitive equipment, protecting it from damage. SPD should be installed at the service entrance and at downstream locations to provide comprehensive surge protection. Regular maintenance is essential for ensuring the safe and reliable operation of electrical equipment. Electrical equipment should be inspected regularly for signs of damage or wear. Loose connections, frayed wires, and other problems should be repaired immediately. Electrical equipment should be kept clean and free of dust and debris. Electrical equipment should be tested periodically to ensure that it is operating properly.